Hello, calculus friends. Today we get to do something that I really like. It's called Newton's method. So this is a way to solve a whole bunch of equations that previously we're not able to solve. So for example, solve x squared is equal to sine of x. So for one thing, right now we're not able to solve this because this would require us taking the square root of both sides. Then we'd have the square root of sine. Well, in order to solve for this x, we would have to get rid of that square root and get rid of that sine. So then we would have sine inverse of this, and it just keeps going in a circle and we can't solve. Okay, now the sine graph would look like this. It goes up and down. If you look on the negative x-axis, it goes down and up. And then x squared is a parabola. And there's two solutions. Of course, there's the easy solution, that's x equals 0. And then there's another solution over here. And then that's the question. Where is that solution? Well, the first thing you do is set it equal to 0. So you can subtract whichever function you want as long as they're both on the same side and it's set equal to 0. Then call that the function f of x. Now, take a look at that function. So if you graph x squared minus sine of x, and this is pretty close to the origin, so I don't have to go that far out. Let's say from 0 to 2. And then I need to see where it equals 0, so I can make this pretty small, like -1 to 1. And assuming that's 1, then the answer would be like a 0.8 or something like that. But that's not really why I'm showing you this graph. Why I'm showing you this graph is because what we could do is make a tangent line using the derivative. Once you make the tangent line, then that's just y equals mx plus b. So you could take that and set it equal to 0. Well, if you have the tangent line, let's say we use 1 right here. So put a point right there, and then you make the tangent line, and then where it crosses the x-axis is actually going to be very close to where this one crosses the x-axis. That's Newton's method. So now let's actually do it. So take the derivative. The derivative for x squared is going to be 2x. The derivative of sine is cosine. And then what we need is a guess. So I'm just going to guess that the answer is x equals 1. And then we're going to find the tangent line there. Well, for one thing, I need to know what the y value is. So substitute the 1 into this function. So that's going to be 1 squared minus sine of 1. So 1 squared minus sine of 1. Make sure the calculator's in radians, good. So that means that y is equal to 0.159. Also take the number 1 and substitute it into the derivative. So that's going to be 2 times 1 minus cosine of 1. 2 minus cosine of 1. There's a random thing in there. 2 minus cosine of 1. So that means that the slope is equal to 1.460. So now we've got the point and we've got the slope, so we could find the equation of the line. So y minus 0.159 equals the slope times x minus the x value. And now we're trying to find out where the function equals 0, so you could set this y right here equal to 0. And then solve for x. So what I could do is divide both sides by 1.46. And then after this is gone, then I could just add 1 to both sides. So take this one and add it to this side. And then that's what x equals. Now before I type this in the calculator, notice what this says. So it says x equals whatever your original x is, that goes right here. And then this number was the y value, and this number was the derivative. So it's x minus the function divided by the derivative. Okay, now to find out what it actually equals. So that would be 1 minus 0.159 divided by 1.46. And this process basically says, well, you know what? Your guess of 1, it's not bad, but the actual answer is closer to 0.891. Now, what you do is, now take this, put it back in here, go through the steps again, and then you'll get a guess that's even more accurate. And then you take that, plug it in here, go through the steps again, and you get an answer that's even more accurate. Well, all of that's summarized by what I was just saying right here. So this right here is basically the summarized versions of Newton's method. It also will save us the trouble of having to go through all these steps each time, because it always ends up to be x minus the function divided by the derivative. So then, let me just summarize that. So in general, it's x minus the function divided by the derivative. So in this case, it's going to be x minus, the function was x squared minus sine x. The derivative was 2x minus cosine x. So not only does that right there replace all of this algebra, but also because we're going to need to do it repeatedly, it's going to save us a lot of work. So I'm going to start over. Guess that x is equal to 1. And then this is called x naught or x0. So in other words, I've run this number through the formula 0 times. Now, you can actually do this very quickly on a calculator. So first of all, here's store, your new best friend. So put 1 and store that as x. Now, every time the calculator uses the letter x, it's going to plug in a 1 for x. And then type in this formula with the x's. So it's going to be x minus, and then the numerator needs to be in parentheses, x squared minus sine x. And then that's divided by 2x minus cosine of x. And now the calculator is going to plug a 1 in for all those x's. So then, just like we got on the other page, the little algorithm says your guess of 1 is pretty good, but it's actually closer to being 0.891. Then what you can do is go store that as x, and then get the formula back again. So if your calculator allows you, you can go up until it's highlighted, hit enter, and when you hit enter again, it's going to plug in the 8.91. So x number 2 is a 0.877. If your calculator is a little bit older and it doesn't allow you to go up like this and highlight the different things, that's okay. Just put second enter, and you probably have to do it twice because I just did this. So it remembers the last 10 things that you've done. If you put second enter, it'll put the last thing you did. If you put second enter, it'll put the previous one. If you put second enter, etc. So it turns out that it gave us the same answer twice, and as soon as it does that, that means we're done. That is the answer. X equals a 0.877. Now let's see if it's correct. So go to the graph, and where it equals 0, that right there should be 0.877. So I could ask the calculator, find the 0. So move to the left of it, move to the right of it, and then it says 0.877 is the answer. Okay, so now, without all of the theory and such, let's do one more example. So find two solutions for the square root of x minus 1 equals the natural log of x. And the reason I'm saying two solutions on this one is because we could find one even without Newton's method and even without a calculator. Because if you plug in 1, this is going to be 1 minus 1 is 0. And if you plug in 1, natural log of 1 is 0. So we get 1 for free. X equals 1. Now, find another one. So the first thing to do is set it equal to 0. I'll subtract natural log of x from both sides. Then it would be equal to 0. Then the next thing is you call that function f of x. So the putting it equal to 0 part, so in theory, you're supposed to make it equal to 0, and then you call f of x that function. Well, if you just skip that part and put that as f of x, that saves you a step. That's fine too. The next thing is need the derivative. So the derivative of square root function is 1 over 2 times the square root function. And the derivative of the natural log of x, that's going to be negative 1 over x. And then set up the little formula. It's x minus the function divided by the derivative. And I would usually say you cannot leave this as a complex fraction, but we're just going to type into the calculator anyway, so that's okay. Just as long as you type it in that way, it'll work out. Now we need a guess. So let's see. The natural log function looks like this, and it grows fairly slowly. The square root function basically has the same shape like this, but then it's going to be moved down by 1. So it would be like this. And so eventually the two meet something right here. So then I'll just put a guess. Of course, I could use the graphing calculator, but I like the challenge of just guessing. Is it 10? So my first guess, x0 is equal to 10. Now, store that as x. So clear my mind a little bit and then go 10, store that as x, and then type this in. So it's going to be x minus parentheses the square root of x minus 1 minus the natural log of x. So all of that numerator needs to be in parentheses, and then divided by, the denominator needs to be in parentheses, 1 divided by, and then this little guy right there needs parentheses, 2 and the square root of x, and then minus a 1 over x. and then close the parenthesis, and how good was my guess? It says you probably should have gone with about a 12. All right, so 12.414. Then store that as X. Go back and screen grab that. And the answer is already settling down because it's still a 12 something, 12.340. Store that as X. Do it again. And we got the same thing twice. So that means that once you get the same thing twice, that is the answer. So X equals 12.340. Oh, that's a pretty cool number though. Check it out. 1, 2, 3, 4. It's all got its stuff in order. Good on you, mate.